Good evening. My name is Steve Eckeren. I am a program manager in the failover cluster team. My team is the one responsible for creating the infrastructure for the private cloud and the infrastructure for things like Exchange Server and SQL always on. Jose Barreto, did I pronounce it right? Is presenting with me this afternoon, and he's going to be covering the second part. And his part, he's going to be talking about cluster shared volumes. So if you're here to learn about our new cluster shared volumes technology in Windows Server 2012, you're in the right place, and we will get to it. My job is to kind of preface that, talk about what Microsoft has for as far as being a platform for your applications, and if you're deploying applications, why should you use the private cloud, and with failover clustering as the infrastructure. So the first thing that we talk about is going to the private cloud, you're moving physical to virtual. And why would you want to do that? In this case, I'm showing SQL on a physical machine. And you're going to transfer that into the private cloud. We do have tools called Physical to Virtual and System Center Virtual Machine Manager that can help automate that. Or some people just retire their physical and then deploy an equivalent version of the application within the cloud. Why do you want to do that? Well, first of all, let's. When I use the term private cloud, I want to clarify what we're talking about with that term. We're talking about using virtualization. Hyper-V as your virtualization platform. Failover cluster as the infrastructure that allows mobility and high availability. And then it also implies that we're going to be using management tools, and we provide management tools to deploy applications as well as virtual machines. We also have tools for monitoring, Operations Manager, to monitor the health of the physical systems as well as the virtual and the applications, and then also backup. So when we talk about private cloud and deploying to the private cloud, it's not just virtualization. It's an end-to-end solution that allows you to take your applications, easily host them, manage them, back them up, deal with the life cycle of the application and the infrastructure as well. So when we're talking about the private cloud in deployment, one of the things that makes it really nice for your applications is the templates that SVMM has. So you can take a virtual machine and an application, you can generalize it so you can deploy multiple versions of the same thing, and they end up with unique IP addresses and machine names. And it makes it very easy to take one instance and deploy it over and over. We also have the ability to have front ends for your users. So instead of having users contact administrator, you can actually publish your applications or your VMs that have applications in them. People, based on their identity, can go in and you can set which of the things they can deploy, and then they can choose deploying it. So you can give the ability to automate and give people the ability to just go to a website, choose to deploy something, have it available for them to log in and use without using human time. Also, for deployment, when you virtualize, you also have the ability to use client Hyper-V to set up your VM, put your application in it, configure it, do it at your desktop, and then you can take that same VM and export it and then import it into your private cloud and host it. So the mobility of the virtual machines makes it a lot nicer when you're working with applications in providing that dev environment and then easily just taking that virtual machine and deploying a production environment to make it available. Mobility. So one of the things that it can be a challenge with applications is patching the operating system. When you take a virtual machine, you put it on a Hyper-V system, you can patch the host by moving the virtual machine around. You can also use Hyper-V Replica or third-party replication services to take that virtual machine and create replicas at disaster recovery sites. We have an inbox solution that is asynchronous, but there's for your first-tier applications, there's third-party replication that provides synchronous replication solutions. You can take that virtual machine and make sure there's a copy someplace else. So if there's a site disaster, or even if you just have requirements to have a disaster recovery site, and occasionally you have to test it out by doing a failover. We provide the infrastructure for both our inbox and third-party integrated solutions to provide that for you. We'll be talking quite a bit about availability. I'm going to I'll let the rest of the slides talk about the availability features, but just deploying your virtual machine on the private cloud gives you a lot of protection and availability that you wouldn't have if you were deployed on a physical host system. So we talked about why you want to just virtualize. Now, when we're talking in the context of applications, one of the things we like to point out is that in a private cloud, we can understand what the virtual machine health state is. Is it running? Are we getting rudimentary heartbeats from that virtual machine to know that at least the services or the heartbeat service inside the VM is running? But we don't really know if your application's running. And if your application isn't running for some reason, there are some recovery steps we can take that will hopefully allow you to recover that application in a very easy and seamless way without requiring doing a deployment of multiple virtual machines. So VM monitoring, I'm going to spend about the next 5 slides talking about how it works. But the gist of it is that the VM itself, you can set up a monitor and communicate with the host to say, we had an application critical event. I'm going and send it to the host that message, and then the host will actually shut down the VM. It'll do a graceful shutdown, and it'll restart it on the same host. Then within an hour, if we get the same signal from the application inside the VM again, we will shut down the VM, and we'll actually move it to a different host, because it could be that the particular host that it's on, and in a private cloud infrastructure, you don't really know where your application is deployed to. It could be that particular host is having a problem keeping your application from doing, say, networking out to a specific, or out to your customers. If that fails, we can get notified, and then we'll actually rehost it onto a different node. And if that fails, we'll move it through the cluster until it finds a place where it can be hosted successfully. And the way we detected it, or architected it, was that we wanted to make sure that we were going to behave well in hosted environments. When I talk about a hosted environment, I'm talking about where the person running the infrastructure or the company running the infrastructure doesn't necessarily trust the people that are running the application inside the VM, and vice versa. So we wanted to make sure that if the people running the virtual machines wanted to not expose specifically the application or the processes running inside their virtual machine to the host infrastructure, that we provide an architecture that would not expose that kind of information. We also wanted to give the hoster the ability to turn it off. So if an application inside a VM says, I'm having a problem, recover me, it may be the hoster decides that's a value add and you have to pay for that. Or it may be that they don't necessarily trust all the VMs that are being hosted and that they have some tenants in which they want to turn it on, and some tenants, or they've had bad experiences where they want to turn it off, where if they get a signal saying there's an application problem, do they react to it or not? So it's flexible. We do have monitoring in the guest that you can configure to make it so that just out of the box you can use this feature, and I'm going to demonstrate it in a moment. And when you enable inside the guest that you want to have something monitored and signal to the infrastructure there's a problem, that configuration travels with the VM as it moves around different servers in a private cloud, but it also travels with it as it goes between private clouds. So let's talk a little bit about how it works. So in this diagram, on the right-hand side, we have the parent partition, which represents the host. On the left-hand side is the VM, which represents the virtual machine. Inside the parent partition, there's a component called the Virtual Machine Management Service. That's a service that manages all the virtual machines, starts them, stops them, allocates resources, does all that work. Inside the VM, when you have the integration components installed, there's an integration component called the Heartbeat Service, and it runs as a Windows service. And its job is to get heartbeats, which happen once every 5 seconds from the virtual machine service through this VM bus, get the heartbeat message, and respond to it. What we did in Windows Server 2012 is we added the ability to flip a bit. So when there's a problem that happens in the heartbeat service, the heartbeat can go from the VMM service, goes to the heartbeat service. The heartbeat service will then flip the bit on that message, respond back, and now the virtual machine management service understands that something inside that guest just signaled to it there's an application critical state. It becomes a property of the VM. It can be queried via WMI that particular state has been flipped from healthy to unhealthy. And the virtual machine resource that monitors that specific instance of the virtual machine, every minute, by default, it can be tunable, but by default, every minute it does a health check. And when our resource does a health check, it'll see that status is toggled, and now the virtual machine resource, which is a cluster entity, will be aware that there's an app critical state. Cluster service becomes aware of it. It is signaled specifically that it's an app health detection problem. And so we do a different failure process than if it was some other type of VM failure. For instance, I mentioned that we'll gracefully restart it. A normal failure of a VM would mean that we would basically turn it off and then recover it on another node. But when it's app critical, instead of turning it off, we gracefully shut it down so that we have minimal impact on the other things running inside that virtual machine, gracefully shuts down and restarts. So the third piece is on the left-hand side. So the heartbeat service, we added this COM interface. And this COM interface allows something inside the VM to signal to the heartbeat service that there's an app critical state. You obviously have your application, which is the thing that's most important. That's what we're trying to protect. And then you need some sort of process that can detect that there's a problem and communicate to that COM interface to go ahead and set that bit. And this monitor piece can be our inbox that we provide with if you're running Windows Server 2012 or 2012 R2 inside of your virtual machine. And there's third parties that are looking at creating their own monitors and using this interface to signal the host infrastructure. But since we wanted this to be able to just work out of box, and as we created it, we actually have our own built-in monitor, which I'll show you in a moment. I talked about that we architected this with the thought that we wanted the hoster to be able to have control over when they want to allow the virtual machine to react to this app critical state, and we wanted the people managing the application to have the ability to actually set and have the logic based on their application of when that signal should be set. So on the parent partition, what we've done is in the VM settings, under heartbeat setting, there's a checkbox that says enable heartbeat, enable automatic recovery for application health monitoring. It's checked by default. So that means by default, if something inside of a VM signals, the host infrastructure will react with our failure policies. And it also relies on that heartbeat mechanism. So if you uncheck this automatic recovery, we'll still get the signal that there was an app critical state, but the cluster won't take an action. It won't restart it. It won't restart and move it. If you uncheck the enable heartbeat monitoring, obviously if there's no heartbeat, we can't do the other thing. So the automatic recovery for application health monitoring is dependent on it. But if you uncheck that, just for your information, the heartbeating still occurs. It doesn't affect VMMS from sending the heartbeat. All it means is the cluster is not going to react if for some reason those heartbeats fail to come back. So if for some reason the operating system inside the VM stops responding to the heartbeats, if you uncheck it, VMS will note that heartbeats haven't come, but the cluster won't take any action. With it checked and the heartbeats stop coming, even though there's not an application detection toggle, we will go ahead and recover that VM. So if you uncheck that, the app health monitoring, we also still register an event. And VMS, the property of the VM, still has indicates that the VM is in app critical state. And in our UI, we'll still show the VM has signaled app critical state. We do this because we do have third parties that are interested in providing different recovery mechanisms than just restart or restart and move. They want to add on some logic, if they can communicate with the host and the guest. They want to add components that can do better logic of what the failure actually was. And so we provide the infrastructure to still have the signaling. It's just that we won't do the recovery actions, and their component would be the one that would be doing the recovery actions. So I mentioned that in 2012 and 2012 R2, we do have an inbox ability to set up this monitor piece. And we can actually make it so you can specify a service or event that will trigger the app critical state to be signaled to the host. The layering looks a little bit like this. If you do if you monitor a service, basically what we're going to do is wait for the service control manager to tell us that the service failed, and then we will take that event. We use task scheduler tasks to monitor for those events, and then we have a script that task scheduler calls to call the COM interface to set that toggle. So since it's a 300-level course, one of the things I'll point out is that if for some reason you're interested in knowing how that COM interface is triggered, for instance, an application itself could have, oops, I pushed the wrong button. There we go. An application itself could have called the COM interface directly if for some reason it got into some sort of state and it was had the ability to call it. So you can actually look at our, configure this. Here's our PowerShell commandlets. Each of the commandlets has help. You can configure it to monitor a service or look for an event. And then go into Task Scheduler and look at the script that we attach to. Open that script and you can actually see the code that we use to do that trigger. So if any of you actually create applications or are interested in either creating your own monitor or integrating with it, that's the best way to get a sample. If you have permission, so you logged into your host and you're in Failover Cluster Manager, and your login that you're logged in with the host running Failover Cluster Manager also has permissions to and the networking ability to connect to your guest, then we made it easy by in Failover Cluster Manager, you go to the virtual machine, you right-click on it, go to More Actions, and we have this action called Configure Monitoring. When you open that up, it will connect to the virtual machine using your credentials, and if you have permissions enough to get the operating system to respond with a list of the services, we'll post them here, and it's as easy as checkboxing the service you want to monitor, and then pressing OK. And then we communicate back to the guest and hook up that monitoring piece to monitor that service. And if that service goes into a non-running state, it'll trigger that application health detection. So when you compare app health monitoring and just deploying virtual machines on your host cluster, what you're gaining is monitoring the VM. The host cluster provides you the VM mobility, and both of these features actually provide you some recovery from issues that cause the host OS or the OS inside the virtual machine to fail. For a host cluster, the heart beating process, checking to make sure that the heartbeat service can at least respond with a packet, is a health check that we have that's built in for all virtual machines. And then when you add app health monitoring, you're adding on that extra ability to detect other events and service failures and detect the failures. Guest clustering. So we talked about deploying your application to a virtual machine, and the virtual machine can move around your private cloud. We just talked about you can add extra monitoring capabilities for the virtual machine itself, or the applications running in the virtual machine. But the next level of availability is actually deploying a cluster within a cluster. We call it guest clustering. And in this diagram, the darker boxes are the physical hosts connected to shared storage. And then on the physical host, you create one or more, or two or more virtual machines. And inside those virtual machines, you configure failover clustering. And the advantage you get there is failover cluster proactively has code to proactively check the roles that it's monitoring, verify that they're actually working, not just that they've indicated a failure, but do health checks against them. And then the virtual machine can, or the application itself can be stopped on one virtual machine and started on another. And why is that interesting? For one thing, it protects you from classes of failures such as registry corruption. If you have, in this case, I'm picking on SQL, but SQL is just an example. It could be any application. If for some reason your guest virtual machine A has some sort of registry corruption inside of it, or somebody did something, deleted some files, and that application that can no longer run there, we have a whole new virtual machine operating system environment registry waiting in another virtual machine to take over. So it gives you both the proactive as well as gives you better protection against the different failure scenarios that can happen that causes applications to go out of production. So just a general diagram. When you configure a guest cluster, again, the darker machines are physical. The switches you see on top of those would be Hyper-V virtual switches. You need, for your guest cluster, depending on the workload, if it's a workload that requires shared storage, in 2008 and 2008 R2, it would be an iSCSI storage solution that you would need for your guest cluster. And then you need a couple of networks that you can communicate both out to the world, well, at least one out to the world, and an internal network so that we have redundant paths between the guest clusters like you have physical clusters. In 2012, we introduced synthetic fiber channel. So in a lot of our customers, they run on fiber channel. They didn't want to deploy iSCSI in their environment just for guest clustering. They wanted to use their existing fiber channel infrastructure for their shared storage for their guest clusters. And so we introduced the feature synthetic fiber channel that allows you, instead of, for the storage network, instead of having the Ethernet and a Hyper-V virtual switch, you create a virtual SAN in Hyper-V and connect your guest clusters through that to your infrastructure. You create separate LUNs for your guest cluster that you're running host clusters, and those LUNs get LUN masked and zoned just like a physical cluster. It needs to be LUN masked to both sets. And then the virtual machines, both of them can live migrate and do everything that you would normally do with any of the nodes of a guest cluster. So now if we look at host clustering, application health monitoring, and guest clustering, what we're gaining with the guest clustering is app mobility in the virtual machine, as well as that allows for both failover protection. So if there's a failure, we'll move it. But also an advantage of the virtual machine guest clustering is that if you need to update the software of your application or the OS, you can fail over your application to the other side. And on the original node, do your updates, bring the application back, update the second one, just like on physical clusters, and keep your application in production as you're going through that either OS or application upgrade. Also is very helpful with things like Patch Tuesday and other scenarios like that where you need to do updates. So guest clustering and VM monitoring. So a question I get asked a lot is, should I use one or the other, or can I use them both? The answer is you can use them both. And the way to configure it is inside in the guest, you go into this, each of the virtual machines in the failover cluster, go into services, go to the properties of the service for the cluster service, and go to the recovery tab. And you change the second and the subsequent failure action to take no action. And what that does is it means with this policy right here, the behavior I'm going to get is the cluster service fails, it's going to restart. Cluster service fails again with the take no action, causes service control manager to signal our process, and we'll go ahead and restart the VM. We'll shut it down and restart it on the same node. If it comes up and it has another problem, we'll shut it down, move it to another node, restart it, and so on until we find a good home for that virtual machine. From the host side, after I change the services recovery action, I can just right-click, because in my scenario, I have access from the host inside to the guest. I can just check mark that cluster service. That leads me to my demo. And if you give me just a second, I'm going to set it up. I think I'm doing okay on time. Yay. Okay. Okay. This screen right here, I think it's big enough for you to see it, is my host cluster. And I have 2 virtual machines running. Each of these virtual machines is a node of a 2-node guest cluster. I'm going to bring it down here so we can look at the states. Over here is my desktop system back at work, and I am going to start a little video. I'm actually going to pause it real quick, because it takes me a little bit more time. Now the video quality is going to be based on my network throughput from my office to here, and the networking between these places have been less than perfect. I'll let it run on the side here while I do the rest of my configuration. Now this window is going to show me node 1 of my guest cluster. Inside my guest cluster, I have 1 role running. It's a file server. It's a standalone file server that I configured the file share to be continuously available. So as the file server itself moves from node to node, it will stay up and service its clients. And I'm going to open up the other node of the cluster, the guest cluster. So if you notice, this is TechEd Ready 2013 FS. My share is dogs. Just to prove to you, just a second. Anyways, not letting me go back to my desktop easily, but this is actually reading this file. And this is an MP4 format. It's non-cached, so some of the jerky experience when I fail over is going to be expected because it's not cached, and I do that just to show that we maintain our SMB session state, and there is a slight delay as things transfers over, but it's just a small delay in I/O. Right now it's on node 2. Here's node 2 of this cluster. I can go into Process Explorer. Need to run it as an administrator. Find the cluster service, because it's right here. I'm going to right-click. So the file server, this file server is running on node 2. I'm on node 2. It's a clustered file server. I'm going to kill the cluster service on node 2. And what we'll see on this pane is that it's showing node 2, now it's showing node 1. You see a small delay in the I/O for the video. And now it resumes. And now this video is actually running off of node 1. I'm going to actually close that because the rest of my demo doesn't need the video, and it's a little distracting. But if you also notice down here on my host cluster, the VM stayed running. If we go to the nodes view on this node, my cluster's down. Based on those host policies that I showed you, first action was restart the service. The second one was take no action. Because it's restart service, the application health detection didn't kick in because it only kicks in when that's set to no action. But Service Control Manager itself, within a minute or after a minute, will restart the cluster service, and the node will join back to the cluster. Now, my file server is still on node 1, but now, since it restarted, it'll be part of the cluster, and it can fail back. And I'm going to watch it, and I'm actually going to cheat a little bit because it takes a minute, and I'm trying to be good and give Jose as much time as possible. I'm going to actually start the cluster service and not wait for that full minute. Oh, it's running. It has restarted, and now it's up and running. Good. So I talked long enough. So now it's up and running. So now to show the application detection part, we'll go back to Process Explorer, and I will find the cluster service again, which pops up in the same place. Right-click on it, and I will kill it again. Now, the is-alive process of the virtual machine, there you go. It just shut down the node. And in the bottom left-hand, you'll see it in a second. It'll detect that, and it'll go from running to stopped, and then it'll start it again. The threshold, the is-alive process from the virtual machine happens every minute. So if I happen to do this right before that, it's very quick. If I do it right after the heartbeat, it can take up to a minute to detect. And if that's too long, you can go to your host, right-click on it. Actually, go down to Resources. Go to the virtual machine resource, right-click on it. Go to Properties. Go to Advanced Policies. And right here, there's a thorough resource health check interval. And that's what, in some of our documentations, you'll be referred to as the is-alive check. And this is the proactive check to verify that the virtual machine is running. The default, if you click here, the default is 1 minute. But if you click here, you can actually set how often that happens. Default is 1 minute. It's not a bad default. But if for some reason you're using app health monitoring and you want it to be a little bit quicker, you can bring that threshold down so that health check happens more often. Now, there is a bit of code that runs during that health check, so you don't want to run it like every second. It'll not be performant. But bringing it down to about 20 seconds is usually pretty reasonable. And then you have a 20-second window in which that message comes down to the host in which it can possibly react to it. So if you stop the cluster service on purpose, it does not affect app health monitoring, only when the service has failed. That's why I had to go into Process Explorer and kill the task instead of just shutting it off. So if you gracefully shut it down, like the server's shutting down, and you just go into Service Control Manager and say stop, that won't trigger app health monitoring. If you have to kill the process for it to be detected as a failure and cause this process to occur. And for your applications, it would be the same. If your application happens to be a service and you configure it for a service, the service can shut down as fine, but if your service terminates unexpectedly, that will trigger it. With an event, any time an event is triggered, it doesn't know the difference between graceful or not. And any event that you configure app health monitoring for needs to be an event that you're confident when that event fires, you need it's good for the recovery action to take place. All right, with that, I'm going to go back to our slides. And Jose is going to take over from here. Thank you.
All right, good stuff. So it's interesting to see. We came a long way in providing virtualized workloads with a lot of protection, right? And we're going to take that one step further. And the idea here is that, first of all, we acknowledge that most workloads are virtualized. That's a fact. And it's only going to get more and more virtualized. And if you're here, you care about HA. So you want to make those VMs highly available. So you saw that we can do host clustering and we can do guest clustering. Now, you can also, as you saw, combine the two so that you have a little bit of monitoring, and then if that doesn't work, you can do you can restart the VM as well. Now, there is one problem though. Today, in order to have guest clustering, you need to have shared storage for your VMs. And if you are doing that, that means in up to Server 2012 that you're either doing iSCSI to the guest or you're doing virtual fiber channel. Now, you probably heard me talking about the fact that we can do storage spaces, cluster storage spaces, that we can do file servers. And if you're trying to combine guest clustering with these technologies, you'll hear people say, oh, so I have to set up an iSCSI target somewhere in order to make that happen. Guess what? That's no longer the case. The idea here is with this new capability called shared virtual disks, we now will let you have a simple guest clustering solution where you can simply share a VHD file for your data disk. So, of course, the VMs will still boot from their dedicated OS VHDs, but you can have now a number of shared VHDs shared with both VMs or multiple VMs, and the idea is it will just be configured as a shared VHD from a host perspective. From a guest perspective, it is a shared SAS device that is ready to be used in a failover cluster, right? There are two scenarios that we support. So there is using cluster shared volumes directly. So if you have, let's say you're using a 2-node cluster, for instance, one of those new cluster-in-a-box machines that we keep hearing about, and you're using, let's say, storage spaces. You have cluster storage spaces. So now you don't have to set up an iSCSI target. You don't have to have a fiber channel solution. You can simply, on the CSV that is provided to you by storage spaces, you will then create a shared VHDX. Same thing for SMB. You can create the scale-out file server, and then you share the VHD there. Important pieces here is we enable those scenarios that are used for the type of storage that's more affordable. We also have another benefit, which is the fact that you can completely separate your guests from your hosts. So today, when you expose iSCSI storage to the guest, you're essentially wiring your guests up to a resource that is typically shared. And then you have to be careful about the security. You have to be careful. You can accidentally, unmask things. And you also have the notion that you have to wire that network down to the guest. So very commonly today, we have a back-end network that is used for storage and a front-end network that you wire down to the VMs. Maybe your iSCSI target's not wired to that. So this eliminates that need to wire things down. Same thing for virtual fiber channel in a sense. You don't want to unnecessarily expose infrastructure to the guests that they don't have to. In fact, with this capability, you can at some point be using iSCSI, at some point be using fiber channel, at some point be using storage spaces. And from a guest perspective, it will all look exactly the same. It looks like shared SAS from inside the guest. So let's take a closer look at the CSV scenario here. So this is actually taken from that nice poster that you get, with Hyper-V that has all the scenarios. So I took a piece of that poster, put it over here, right? And what you see here, I have 2 nodes. Inside the 2 nodes, I have 2 virtual machines. So they have their VHDX with the boot disk. Those are dedicated, but they have a shared disk here that goes to this one shared VHD. Okay? So in this case, 2 VMs, 2 Hyper-V nodes, a separate disk for each for the OS, and a shared disk for data. In the same fashion, I can create a shared virtual disk with the scale-out file server. In this case, I have my scale-out file server here at the bottom. Same principle, dedicated boot disk for HVM, and a shared VHDX here in the middle. Okay? A few interesting things that are happening here is when you configure this, it is essentially the same configuration for both cases. You just basically expose the VHDX, and it just happens that one is in C colon cluster storage volume X, and the other one is in / file server name. Okay? Let's talk about how you deploy this. So that's a great thing that we're doing here is as we provide this, we're spending a lot of time with the teams. This is a cluster feature, but it's not only a cluster feature. It's a cluster feature that also has support from the Hyper-V folks because we're integrating with their storage. We are also integrating with VMM so that you can have this capability managed through Virtual Machine Manager as well. So you can actually do this through PowerShell, through the Hyper-V Manager, or through VMM, okay? Inside the VM, you actually just see a shared SAS disk. So inside the VM, you can even use an older version of Windows because essentially we pass failover cluster validation. So we are actually stating support for 2012 and 2012 R2 inside the VM. But I've seen folks trying even older versions, and the only support limitation here is we don't have time to test going down level indefinitely. But the behavior from inside the guest is you load the integration components, and you just run validation, and it will see the shared disk and say, yeah, that's a valid shared disk. I can see it from both modes, and I will accept that as a cluster resource, right? That's as simple as that. Couple things I want you to think about. One is anti-affinity. If you want to make this solution highly available, you want to make sure that you don't deploy the two VMs on the same host, because that host then becomes a single point of failure, right? So you want to make sure that you spread the VMs across multiple physical nodes, even though they are guest clusters. The other thing is heart beating, as we were talking about, right? The heart beating is controllable. If you're deploying a large number of shared VHDXs, it might be required for you to look at the time it takes to, when you're doing, for instance, a migration, and to make sure that you don't trigger that accidentally. We're going to talk about that. So how do you do this? Very straightforward. When you go add a VHD file to your VM, now you have that checkbox, Enable Virtual Disk Sharing. What that does, it uses our new capability, and your disk will be shared. Obviously, this has to be not the primary disk that you boot from, it has to be a data disk. The other thing, it must be on the SCSI controller. Okay? Always keep that in mind. It's on the SCSI controller. If you're interested in doing more with SCSI controller, by the way, remember that Generation 2 VMs are now all SCSI, right? So we can even boot from that, but refrain from sharing the boot disk. Don't do that, okay? Another thing that's important, you will find this feature under the advanced feature options of the hard drive. So we've seen some folks, especially when you're trying this for the first time, you don't see the advanced capability. You go ahead and you apply before you check the sharing. So do not do that. If you do that, it's not shared. You have to remove it and add it again with sharing. Okay, you can't change that. You have to set it as you add the VM. Okay? How do you do it with PowerShell? You know me, I like my PowerShell. So the idea is you can do all this through PowerShell. And it's actually very similar to what you do on a regular basis. You say new VHD, there's no difference there. Create the VHD in whatever place you want to create it. In this case, I'm using the local CSV volume. And then you add the VM, the hard disk, to the VM, And that's something you could never do before. Add the same VHDX to two VMs. The only thing you have to remember, right at the end, dash share virtual disk. It will automatically imply that you're doing it on the SCSI controller. You don't have to specify. It just knows when you specify that. How do you tell that you're using it? There is now a property called support persistent reservations. If that is set to true, that means that you are sharing that disk, or you have the ability to share the disk. In the end, from a technical standpoint, what allows us to actually share that is the fact that you have the ability to do these reservations of the disk. So one node comes in, makes a reservation, the other node can come in, and you can do the arbitration of the cluster resources. As you do with physical disks, we will do it with these shared virtual disks, okay? Another thing in VMM, you have now the ability to also use this shared disk across service tier. So how do you do this in VMM? In VMM, you now have the ability to create these clusters, guest clusters, from the service template infrastructure. So you go there and say, I want to create a SQL service, but I want that SQL service to be a highly available service. So you say, oh, I want to have between 2 and 4 nodes, and I want to do this. And when you're creating the disks for that template, you just have to specify share the disk across the service tier. So that's how you do it. From inside the VM, it's really even hard to tell that you're using something special. From inside the VM, you see disks that are the new Microsoft Virtual SCSI device, right? In that case, you see some are online in some nodes, some in other nodes, because I'm doing cluster shared volume. They're spread across multiple nodes. And they look like regular disks. You go in disk management, they show up, and that's all there is to it, right? So very, very straightforward. Let's take a look at this one in action. So I have here a system that has this configured. So I have one virtual machine running on this node, and this is what's inside the virtual machine. So what you're going to see here is that this virtual machine is running a SQL server, right? And if you look at the disks, you'll see, oh, okay, I have a witness disk, and I have a cluster disk. That's nice. Now, if I go over here at PowerShell and do a get physical disk, you'll see that I have 3 physical disks in this VM. If I do a get disk to see what type of disk that is, you see that one is a regular IDE disk that you boot. The second one is our new Microsoft Virtual Disk, which essentially is our new shared SAS, the new SAS disk. So our SCSI disks, before this release, they were essentially just SCSI disks. Now they are actually SAS, meaning that they support the full semantics of sharing with persistent reservations and all that. So it's really not much going on here. If I do disk management, you look here, have regular disks, boot disk, a couple of disks in disk management. Now let's look at this VM, how it's configured. I'm going to go over here to the settings of this VM, right? And you're going to see that no difference here. My boot disk has a VHDX file, and it's running regularly under my IDE controller. Now, I do have these other 2 disks, and if I expand this and I look at the advanced feature, you will see that I have enabled virtual disk sharing. So that's all there is to it. You check this box, right? Obviously, I can also do this through PowerShell. So if you look at my PowerShell here, I look that I have 3 different disks. If I do a get VM hard disk drive, and then I can see that. Now, if you look at this, you will see that I have on this VM the OS disk, the witness disk, and data disk. Look at the path. I'm going to go in my other, I'm going to go in the other one, right? And you're going to see that I have a similar set of resources. If I do a get VM hard disk drive dash VM name VM5, you see that I'm using a different boot disk, but the same disks. And if I do a select star here, you're essentially going to see the new property that we talked about, support persistent reservation is true. Okay? So it is as simple as that. One thing that I would like to show also is how you do it from VMM. So in VMM, if you're familiar with it, you have a place where you have your VMs, you have a fabric, and you have also the ability to create a service template. So I do have a service template here. I'm going to go ahead and open the designer. And in this service template, you'll see that I have a single tier. And in this case, I have a couple of things it's complaining about. One is that I'm not connected to any VM network. I can quickly fix that. Now select one network here so I can do that. So I fixed that problem. The other thing I was complaining is I don't have any disks. So let's go ahead and take a look at the disks for this configuration. So I'm going to go over here. I'm going to give myself some space. So you see that I have here, I want to go ahead and say, yeah, that's the deployment order. Let's look at my hardware configuration. So on my hardware configuration, I don't have any disks here. I'm going to go ahead and add the disk. Okay? And go ahead and take a disk from the library here. So I'm going to use a small VHDX for my boot disk. And you see it says contains the operating system. That's good. Then I'm going to go ahead and create another disk. Okay? And I want to use a large VHDX here. Let's see who's paying attention. Okay, so I can't share it. Why is it? I have to use SCSI. All right, I can do that, no problem. I'll put this SCSI adapter here. I'm going to go over here and say, oh yeah, I want to do a SCSI. Cool. So I go over here, and there you go. I can share my disk across the layers. So that's all it is to it. And then when you deploy it, the new service template has this notion that first node gets deployed. I can do a script, special script for that. And then the second node, when it gets deployed, can do a different one. So I essentially can go ahead and create a tier of service that has a SQL instance running and with a cluster that I can fully automate. So you can imagine now I can have this service template that in the past we had this very common thing, right? That you create a multi-tier application, have multiple IIS service. That was fine because IIS, you can basically create multiple instances very easily, right? You deploy the code. Now we can actually do a cluster version of that because we have the ability to create the shared virtual disk, and the service template now can have these actions for the first node, multiple nodes. So first node, you create the cluster. Other nodes, you add the node to the cluster and the shared storage there, right? So that is essentially the gist of it. And when you're, let me go back here to my presentation. You just have to remember a few things. For the Hyper-V hosts and for the file servers you're using for this, you have to be using Windows Server 2012 R2, okay? That is a requirement. For the guests, for the virtual machines, we are testing 2012 and 2012 R2, right? And you have to have the integration components installed because that's how you get the new virtual SAS inside the guest, right? And you could use older versions, we just don't have the test coverage, and so we don't support it. Few things about disk format. This is only for data disks. You should never share boot disks, right? This is only for VHDX. We actually use the metadata on the VHDX to store persistent reservation information. So you cannot do this with regular VHDs. For the boot disk, you can do whatever you want. For the shared data disks, you should always use VHDX, okay? You can use fixed disk, you can use dynamic disks, but we don't do differencing. And the idea here is that for data disks, that's never really a requirement, right? Differencing disks is more for OS disks when you're doing the classic, you know, have a base and then you create a diff on top of it. So this is for data, so we support fixed or dynamic. In terms of backup, we always tell you to do backups from within the VM. So guest-based backup. Why? Because the host is sharing that with multiple VMs. So if you start backups from the host, it wants to have the VM as a unit of backup. When you're doing this in the tier, there are multiple VMs using that same VHDX that could cause trouble. So we always say, do it from the guest. By the way, that's not a privilege of the shared VHDX. That is true for iSCSI to the guest. That's true also for virtual fiber channel. We tell you, back up from inside the virtual machine, okay? Also, the notion here is that you want high availability. So we are testing all the different combinations, all the different types of failovers and moves. So the guest can fail, right? If the guest fails, we'll fail over to the other node. The host can fail. If the host fails, the VM goes down, but the other VM survives, and we will continue to run there. As long as you pay attention to the affinity, right? You don't want to deploy the same host has all the VMs, then that is a single point of failure. And your file server node, as usual, can fail, will have the other node take over the role, okay? So transparent failover on the file server side. You can also, while doing this, move the CSV volume. So you can move that resource around. You can also move the VMs. You can do a live migration on your VMs running this. We will properly move the memory to the other side, reestablish and move it there. Have to be careful with the timing of that, right? So, but there are guarantees that when you do these migrations, you actually will be able to survive that, all these different types of moves and migrations. One thing you cannot do is storage migration for the shared one. So if you're doing a migration of that VM, you are free to migrate the boot disk, but you cannot migrate the data VHD. Why is that? Because that disk is being referenced by multiple different VMs. And to do that at the same time for the multiple VMs is, let's say, a complex problem, okay? So in Windows Server 2012 R2, you can freely move the non-shared disks, but you can't move the shared one. If you need to make that move, then you have to remove it from sharing and then put it back. So there's downtime for that, okay? So a little summary of what we're talking about here. So with the new shared VHD, the shared virtual disk, you can now do the same kind of shared storage for source spaces, SAS, fiber channel, iSCSI, SMB. Everything behaves in the same fashion. You create the VHD file, you add to the VMs with the dash shared virtual disk, or you, in the GUI, check that box, and you're good, right? What shows inside the VM is a virtual SAS instead of a virtual fiber channel LAN or instead of an iSCSI LAN when you're using the other options, okay? And you can take a look at the other stuff. I want to just spend some time looking at troubleshooting, So we have a few things that we have introduced to properly support this new scenario. So we have a few new performance counters, events, and a little note on the filter manager. So first, we have performance counters for the shared VHDX. So you can actually go and look at what the traffic is like on that specifically. And we also have some specific things about the fact that it's shared, so what's the queue length, if you have any errors, the time it took to mount the VHDX. So all these are new set of performance counters under Hyper-V shared VHDX. Another thing that we have introduced is we now have events for shared VHDX. So we have an operational events where all things that need attention will be there. We have an event channel also for reservations. And we have a debug channel for diagnostics where it records every detail that's happening. That's not on by default as all the debug diagnostic logs, but you can do that as well. I have a little reference on how you use PowerShell to list those events. You obviously can also use the event viewer. And a little bit on the technology, right? So we are using here a filter, a file system filter, to actually provide that functionality. The shared VHDX filter can be looked at if you know what you're doing in terms of your file system filters. You know that there's a tool called FLTMC, which allows you to monitor the filters that are installed in the machine. So a little trivia there, right? You have the CSV filter, the CCF filter, resume key filter, and right there, our new shared VHDX filter. That lives on wherever the CSV volume is. So the filter actually lives on whoever manages the volume where you put the VHDX, right? So that's just a note on how that works. And those are the actual binaries. Interesting note also that we have on the Hyper-V side, we have a matching component that we call the parser. And that is the one that when you say dash shared virtual disk, that one takes care of that on the Hyper-V side and finds the right partner on the shared VHDX side on the CSV, and then they talk and they allow this to happen, okay? One thing that you can do, which I was thinking of demoing before my notebook had a little malfunction today, was you can do that actually only for test, dev, and learning. You can actually experiment this on a single machine if you want to, right? How do you do this? You get a machine, you install the new Windows Server 2012 R2 on it. Then you you enable the failover clustering feature, but you don't have to create a cluster. Just install the failover clustering feature. Then manually attach to any disk that you want to use as a shared disk. Now, granted, this is a manual step, and we don't want to encourage you to do this. That's why the big yellow triangle there. If you're dying to try it out, that is one way to do it. This is not highly available, as my notebook proved, right? If it goes away, you're doomed. You have nowhere to go, right? So this is about high availability. This is more of a scenario for you to experiment with it, right? By the way, when you manually attach, if you reboot, you have to manually attach again. So we don't want it to make it easy for you to play with this in this environment. But if you're doing this on CSV, the filter automatically attaches to the CSVs. So that is taken care of. For the production setup with CSVs, with scale-out file server, you're golden. This is just a little hack if you want to play with it. So that's my unsupported, very important bonus scenario, okay? That's about it. I mean, that's a new scenario we're introducing, and the idea here is to make it much easier for you to implement guest clusters. And we want to make the scenario with storage spaces, with file servers, with scale-out file servers whole. We also want to make sure that there's uniformity between the multiple different types of guest cluster storage that you have. So even if you're using just Fiber Channel, even if you're using just iSCSI, this is actually very interesting because it will make your deployment simpler. Today, to do iSCSI to the guest, you have a lot of work to do in the guest. You have to do a lot of stuff in the target to configure this stuff. If you're doing virtual fiber channel, you have to configure these worldwide names for the guest, and you have to reconfigure when it's actually not one, but two. So it's complex. We believe that even in these scenarios, people might be interested in deploying shared virtual disks. Okay? That's all we had. Thank you. And we welcome your questions. We will be blogging about this soon. And in the meantime, please make sure to fill an evaluation. Any questions? Okay, so online operations. So we do not support online restarts of VHDX. In general, what's happening there are situations where you're sharing between both, and then you have to make a change in the base one. So that scenario is not supported. Unfortunately, you cannot online resize a shared VHDX.
Shared VHDX, and then go and when you add it to the VM, go to the advanced and share it while the VM is running, and it'll hot add it.
Yeah, so you can add more storage, right, to the existing, like add another shared VHDX, but you can't online resize.
Yeah, but you can add them.
Yeah, you can add another one. Anything else?
In your unsupported scenario,
Mm-hmm.
on your laptop. But can we extend your scenario to the VHDX on the shared folder? And then go do the scenario 3.
Okay, so he's trying to extend my unsupported scenario for yet another unsupported scenario. Would it work if I want to do a remote file share to a file share that's not clustered? Essentially, that's what you're asking. So you would have to essentially, on the file server side, load the failover clustering feature, and on the file server side, attach it to the disk that you have the share on, right? And you don't need to do anything on the Hyper-V side, because in this case, you're running it on the file server. But don't forget, this is not supported.
Yeah, so an alternative to that is if you have a file server that's standalone, and you don't want to add a second node for a cluster, you want to use the shared feature, you could make a file server a single node cluster file server with CSV enabled. You can do that as long as that machine has. You can attach an external JBOD, SAS JBOD, that has the SCSI underneath it, and then have a single node with CSV because it's got the SAS JBOD that it can manage, and then do it. But with DAS, no, you can't.
Yeah, in that case, what you would do is you have a standalone file server that you turn into a clustered file server with CSV, and at that point, there's no hack. You have a single node file server cluster, which is what you end up with if you had a 2-node and one fails. That's what you are. So you're degraded, you're not highly available, but you don't need any special attach command or anything.
The advantage is that if your file server reboots, you don't have to manually attach that filter. Because CSV
so you're closer to a supported scenario.
Yeah.
But if you're doing that on a notebook for experimentation, it's a fine thing as long as you understand where you're stepping.
On my demo system, it was on a 2-node host cluster, but sometime Sunday night, one of my nodes physically died. So it's actually a single node host cluster with iSCSI as its back end, and then my guest cluster was actually using shared VHD because it was a heck of a lot easier to configure my demo in the VMs by just configuring shared VHDs than going to my iSCSI target and creating some LUNs and exposing it, et cetera. So that demo was actually running and using shared VHDX with a single node host cluster with iSCSI on the back end. And my iSCSI server is a desktop class 6-year-old PC that all it and it's like 4 gigs, and all it has is DAS disk and doing that. So you can create a very low cost, but still have the CSV and the full use of the shared VHDX in your environment at a very reasonable cost. We call it PC Recycle.
Yeah, I just wanted to comment and say thank you. This was an excellent session. Really appreciate it.
Oh, yeah, thank
Cool.
you guys for coming
Thank
so late at night also. Appreciate it.
All right. Thank you, guys. Oh, one more question. Yes. So we do require the file server to be 2012 R2. Why is that? Because we are actually using the failover clustering that is the R2 failover cluster that comes with that shared VHDX component. So when you're doing shared VHDX to a file server, you need to have that new component in place, and that is new in 2012 R2. If you try to connect to a file server that is an that's a current 2012 Windows server, what you're going to have is on Hyper-V, when they try to do the sharing, they try to contact that component on the other side, and they're going to say, I'm sorry, this file server does not support sharing of the VHDX file. So it is going to cleanly tell you, yeah, you need a server that supports this. The same thing will happen if you try to use a traditional file server. So you must use a scale-out file server. Even if you're doing 2012 R2 and you're trying to do the traditional file server, not the one that uses CSV, but the one that uses the other type of the traditional, the non-scale-out, it will also give you the same message because the component does not attach to anything that's not a CSV, right? And the reason we chose to do that is the way this was designed, it was designed to be associated with the cluster shared volume because we have a set of guarantees there. That's the scenario that we encourage for Hyper-V deployments, so we don't want to send the wrong message. And we only use CSV in the back, either directly or through the scale-out file server. Okay?
But you can still create a single node scale-out file server. It's not very scale-out, but basically when you designate a scale-out file server, if it's single node, it will use the CSV disks that are configured on that.
That's a scaled-in file server.
Yeah. So don't think in your scenario, sir, where you're looking for a single node, inexpensive solution, you can still do a scale out, designate the file server as scale out, and even though it's single node.
Yeah. Cool. Yes. Well, so the question is SQL Server support, Exchange support, or other workload support. The demo I did was actually using SQL Server, right? So no doubt there. And honestly, the workload running inside the VM really can't tell what's going on. What the workload sees is a fully enabled disk that's cluster capable, so it will just think. I mean, that's what virtualization is all about, right? Oh, I think that's a disk. Hey, it passed failover cluster validation. It's a good disk for clustering. I'm going to use it. So if the workload supports failover clustering, it will actually have no way of telling that this is not a legit disk for failover clustering. So that's the whole point, that we don't have to go change our applications to support this scenario. You just simply use the applications that already support failover clustering, any of them. Okay?
Thank you very much.
Thank you.